So today we are looking at our third item that you're going to be able to take pH of, and those are solutions of salts. So how do you identify a salt? Ionic compound. Break it down even more. How would you identify an ionic compound? Metal and nonmetal, metal polyatomic. Okay. So so far you can do the pH of strong acids and bases, negative log of the concentrations, weak acids and bases by adding water to the weak acid or base and putting it in a rice table. And today you're going to learn the salts. So to give you an idea of what's going on here, this whole salt thing is run by the concept of hydrolysis. If you want to take the pH of a salt, it's a salt solution. You're not putting a pH probe in a solid salt. It's a salt dissolved in water. So the reaction of that salt with the water is called hydrolysis. So for instance, I'm going to take the salt, let me see. We'll use this example, KCN, okay? When I dissolve that in water, what ions does it dissociate into? K+. Now the process of dissociation for any of these that we're doing, it's great. It's freaking out again on me. For any of these things we're doing hydrolysis for are 100% soluble. All right, now that this is functioning correctly, looking at KCN, when it dissolves in water, we make K+ and Cn-, correct? Whenever you're doing a dissociation equation, this is a dissociation equation, it's a single-headed arrow right here. I want you to make sure you know that dissociation of something that's soluble is the arrow in one direction. That's really important. Now, in order for us to figure out what this salt's going to do, we need to, the easy way to do this is to look at the parents of this salt. How do we make a salt? You actually know how, and you might not realize you do. There's a reaction that's very common that you always make salts. Yes, an acid and a base makes what? Salt and water. So every salt, they have what I call parents, right? What parent, acid or base, one of them's going to be one of these ions is from an acid and one's from a base. Where do you think the K+ came from? KOH. And where did Cn- come from? HCN. So those are the parents. In order to determine a quick way to determine the pH of the solution, what you can do is look at the parents and compare their strengths. Which one is stronger, KOH or HCN? KOH is a strong base, HCN is a weak acid. Therefore, when I put this salt in solution, it's going to have a pH greater than 7. Now that's really the shortcut baby way of doing it. What's actually happening is the weak part of the salt is undergoing hydrolysis. What the heck does that mean? Weak part of salt undergoes. How does putting the Cn- hydrolysis in water make a basic solution? How would that work? Well, the first thing you need to realize is that when you put these ions in water, only the weak part is going to actually react. If I were to put K+ in water, what can you tell me about group 1 ions and AP equations? They're always soluble. They're always going to be a spectator. So this is not going to react. That K+ is going to stay K+. So you will never see a reaction between the strong part of the salt with water. The Cn- is what reacts with water. Treating this like a Bronsted Lorry now, H is only going to want to move, there's only one thing that can donate the H, it's C, water, so we get HCN plus what? OH-. So taking the weak part of the salt and adding it to water, which is hydrolysis, creates something in solution that will give us pH. This made an OH-. What did we predict the pH to be based on the parents? Greater than 7. This is what's making it greater than 7. Okay? This is the real deal. This is why it's greater than 7. So in short, you always take the weaker part of the salt, add it to water to make your equation, which we will then put in a rice table and treat like every other problem we've done so far. Okay? Does everyone understand what I mean by the weaker part of the salt? You look at where the parent, what the parents were, okay? And whichever parent is weaker, that's the ion, the CN negative, that's going to undergo hydrolysis. The strong one is always soluble. It's not going to react with the water. Okay? So let's jump into doing an actual one of these problems after we do number 13, which is not one of these problems. Write the dissociation equation that describes what happens when that nitrogenous base that has a halogen on it is added to water. So we get CH3, NH3, Cl. This is a dissociation equation. That means it's still solid and it hasn't dissolved yet. So you're not going to be plus H2Oing this and adding the weak part. All you're doing is dissolving this like I did with the first equation. What do I write? Arrow. What ions does this dissolve into? CH3, NH3 plus, good, plus Cl minus. Now that's all for that part. The next part says write the equation which describes the acidic character. They're basically telling you the answer already. If I were to ask, is this acidic or basic, we would take the weak part of the salt. And remember, this came from HCl, which is strong. This came from a weak nitrogenous base. So this is the weak part of the salt. We're going to take that weak part, add it to water, and that's the equation that's going to describe the acidic character. Hopefully we make H3O plus here, and we do, because we're going to transfer an H. We're going to make H3O plus what? CH3 NH2. So this is just trying to reiterate how to write these reactions. Take the weak part and add it to water. Now the next part says write the equilibrium expression and calculate the Ka. We'll do the calculation in a minute. Let's just go ahead. We really can't calculate the Ka because we don't have an original concentration of anything. For now, I just want you to write the equilibrium expression. You better know how to do this part. Products. What do I do with the water? Don't include it over CH3 and H3 plus, just like we did before. Okay? All right, let's go ahead and do the real problems. This is calculating the pH of a salt solution. This is number 3 on the board. Calculate the pH of a 0.700 molar sodium acetate. From this point on, you're going to have number 1, 2, and 3 in this list all mixed up. You're going to have strong acids, bases, weak acid bases, and salts all muddled up. So you're going to have to, first step of any problem is ask yourself, what kind of problem is this? I'm finding the pH of a sodium acetate. Is that a weak acid or base? Is that a strong acid or base? No, it's an ionic compound. Once you identify that, you know that this is a hydrolysis problem. So, first step in the hydrolysis problem is to write your reaction by taking the weak part of the salt. Let's make a prediction. Is this going to be basic or acidic looking at the salt? Basic. Which parent's stronger? The sodium hydroxide. So we're going to predict it's going to be basic. Let's make sure by writing the hydrolysis equation in our rice table. We're going to take the weak part of the salt, which is what? The acetate ion, and add it to water, because that sodium is not going to react at all with the water. And we get a Lowry-Bronsted, Bronsted-Lowry, plus what? OH minus. Ta-da! That's why it's basic. Okay? So now it's just a normal rice table. You all know how to do this. Our original concentration, I know it says here this is acetate, but don't we have for every 1 sodium acetate, 1 acetate? Okay, so this is 0.7. Liquids not included, 0, 0. Have to shift to the right. And good news is we can Donald Trump this. We can trump it. And if you didn't see, I didn't mention this yesterday, but there he is. Up there. There's Donald with his nice toupee or his hair, whatever. Anyway, we can Donald Trump this, and we do have a problem though. I'm going to stop the video and I want you to look at this and see if our next step would be to solve for x, right? And to calculate the pH using the x because that's the OH concentration. But there is something that's really, really not right here that we have to remedy. So the big problem here is that we are given the Ka of acetic acid. What we really need is, because we're solving for a basic concentration, we need the Kb of the conjugate. So that's something that we can calculate. It's not very hard. Knowing what you know about pH and pOH and the pH scale, any ideas? Anyone have any guesses on how to convert from Ka to Kb? The necessary equation to do this is the Kw is equal to Ka times Kb. And I'm going to repeat this. This is mathematically equivalent to saying 14 is equal to pH plus pOH. So this is 1 times 10 to the negative 14. This is exactly the same equation. It's just we are removing the logs. And when we add logs, it's really a multiplication. So this is the equation you need to use. Every single hydrolysis problem in the whole universe is going to require you do this conversion. That's why on the board I wrote, weak ion from salt, add to water, put in a rice table, convert. You have to do this every time. So let's go ahead and do that conversion. We get 1 times 10 to the negative 14th divided by the Ka they give us of 1.8 times 10 to the negative 5th. And what do we get? 5.6 times 10 to the negative 10th. So we can now set up our expression and have our Kb equal to OH minus times HC2H3O2 divided by C2H3O2 minus. And we plug stuff in, we get 5.6 times 10 to the negative 10th is equal to x squared over 0.7. I'm not going to, you can write negligible here. In a hydrolysis problem, I'm never going to have you check for percent dissociation. Don't worry about it. All right, so when we get x equal to, what do we end up with? (1.97 times 10 to the negative 5th. And how do we find pH from that? The negative log of that gives us what? pOH. So pOH is equal to, okay, give me, let's see, we had, in our K, we had 2 sig figs, so I need 2 decimal places. 4.71, so therefore my pH is equal to 9.29. We predicted basic. Is that basic? Yeah, it is. Okay, let's do another one. Let's predict this one. I think I'm going to skip it and go to B, but what would this one be if we were to, let's predict at least what we think the pH range would be. This would be basic as well. I want to work an acidic one, so let's move down to the next one. I'm going to put this guy up here. Okay, so we're doing this one. The job is to find the pH of the following salt solutions. One piece of information I'll give you is that the Kb of ammonia, and this will be given to you or you'll have a chart to look it up on. The Kb of ammonia is equal to the same as the Ka of 1.8 times 10 to the 5th. Same as the Ka of acetic acid. It's weird, but it's true. Okay, so let's identify. Is this a strong acid or base? No. Is it a weak acid base? No, it's definitely a salt because I got a polyatomic ion with another ion. So step 1, take the weak part of the salt and add it to water. What would that be in this case? NH4+. and add it to water. In equilibrium, I'm going to end up with ammonia and H3O+. So we can see that this is going to be acidic. Our original concentration of this is 0.777, 0. So we're going to lose X, gain X, and gain X. So we get 0.777 minus X. We can trump it because it's negligible. This is X, and that's X. Okay. Now what we can do is we can go and write our expression. And I'm going to write my expression just from the information in front of me. So seeing that this is H3O+, I need a Ka, and that's equal to NH3 times H3O+ divided by NH4+. But I have a problem because what they give me, Kb. So I can do this. If I want to put my work together, is equal to 1 times 10 to the negative 14th over 1.8 times 10 to the negative 5th. I get 5.6 times 10 to the negative 10th. So 5.6 times 10 to the negative 10th is equal to x squared over 0.777. What is x, which is equal to my H3O+ concentration? What is that equal to? Okay, and that's moles per liter. So I need to find the pH. If I take the negative log of that straight up, I get, give me 4.68, and that is acidic, and that is correct. Do y'all understand? All right, let's look at the next one. KCl. What's the pH of KCl? So what do we do here? Take the weak part and add it to water. Oh my gosh, they both come from strong parents. Huh, what do you think that means? If they're both strong parents, I heard the word neutral, but the question asked for what the pH is, so I need a value. There you go. Done. Don't you like that problem? I do too. So I'm going to not talk, and I want you to work on this one. I'm going to turn the video off, write it as you write it, and we'll see who comes up with the right answer. You'll need the Ka of acetic acid, and that is 1.8 times 10 to the negative 5th. This is the Ka of acetic acid. All right, so get to getting on this problem. Practice. For those of you at home, if you haven't stopped the video yet, I suggest you stop it right now, work the problem, and, oh, well, it's too late because you just saw the answer. People at home, never mind, well, hopefully you stopped it before. But anyway, when you did this problem, you added the acetate ion to water, found out that you needed the Kb, and you were given the Ka, divided 1e negative 14 by the 1.8e negative 5 to find the Kb, solve for OH concentration as 1.5 times 10 to the negative 5th. Yes, everybody? Okay. Ended up with a pH of 4.82. pOH of 4.82. And we know that can't be because it's supposed to be basic, so we got to get on the right scale. And our pH ended up to be 9.18. And that, my friends, is hydrolysis. And we'll do hydrolysis of polyprotic stuff tomorrow as well.